Hi, today is the continuation of day 3 video. This is the second part to it. What we're going to look at on this slide is identity and no solution equations. Let's take a look at number 7. Now the rules that we had, they're the steps that you took notes on from the first part in day 3 still apply here. So in number 7, when I look at number 7, I have parentheses that I need to get rid of first. So I'm going to use the distributive property to undo those parentheses. I have this 4 minus 4x is equal to, when I apply this distributive property, notice I have a negative 2 out in front. Negative 2 times 2x is negative 4x, and then negative 2 times this negative 2 is a positive 4. Now we have variables on both sides of the equal sign, so we need to move the smaller one. Well, when I look at them, they're both the same, so it doesn't matter which one I move. If it's a minus 4x, to move it to the other side of the equal sign, I do the inverse, which would be to add 4x. When I add the 4x, bring this 4 down, the variables on the left-hand side cancel, and the variables on the right-hand side cancel. I don't have any more variables. But I do have a statement right here, and this statement right here is true. 4 is equal to 4. So there are no variables. They canceled out. I am left with a true statement. This is an identity equation. That means that the equations were identical. The expressions on the left-hand side and the right-hand side of the equal sign were identical. All real numbers work for this equation. Okay, this was an identity. Your variables canceled out and you got a true statement. Let's take a look at the other one over here. Now when I look at this one, I see I've got an x and a negative 7x on the right-hand side of the equal sign. I need to combine those first. So I have this negative 6x plus 8 is equal to, remember there's a 1 in front of that x. 1 minus 7x is a negative 6x, and then I have that plus 10. So I want to get the variables together on the same side, but I notice when I look at them that they are the same. So it doesn't matter which one I move. It's a minus 6x, I want to add 6x. So then I get 8 is equal to, because those variables cancel out, those variables cancel out, 10. Okay? No variables, but this guy here is a false statement, and so if it is a false statement, there is no solution. There isn't a single number that would work for that equation. Okay, let's take a look at, it's not turning, there we go, at my next example. The measure of an angle is 5x minus 3 degrees. Its vertical angle has a measure of 2x plus 12. Solve for x. Well, this is kind of new, this vertical angle. So let's talk about what a vertical angle is, first of all. Vertical angles are angles that are created by two lines. These are vertical angles. And the thing that you need to know about vertical angles is that vertical angles, this is my symbol for angles. Vertical angles have the same measure. So it says the measure of an angle is 5x minus 3 degrees. So they're saying this is 5x minus 3. Its vertical angle has a measure of 2x plus 12. So this is 2x plus 12. Well, if I know that vertical angles have the same measure here, I can set up an equation. If they're the same measure, then 5x minus 3 has to be equal to 2x plus 12. And when I set that equation up, I have variables on both sides of the equal sign. So I move the smaller one, which is the 2x. So I'm going to subtract 2x from both sides. I get 3x minus 3 is equal to, those x's cancel, and then 12. Add my 3. 3x is equal to 15, divide by 3, x is equal to 5. Let me go back and see what they wanted me to do. They wanted me to solve for x. Did I solve for x? Yes. So what you need to know to do this problem is that vertical angles have the same measure. Then you just set the algebraic expressions equal to one another. Okay, the last example we want to take a look at is, again, turn the page, issues. Here we go. And I don't think this is problem number 10. Maybe it is. You can buy a skateboard for $60 from a friend and rent safety equipment for $1.50 per hour. Try to move that. Or you can rent all items you need for $5.50 per hour. For how many hours must you use the skateboard to justify buying your friend's skateboard? Okay, so the question really here is for how many hours. That's what I don't know. So before I do anything, I read the problem, and now I want to set up my variable. So when it's asking for how many hours, hours is what I don't know. So I want to say the number of hours is going to be H for hours. So now that I've set up my variable, defined my variable, I'll go back to the first sentence and then kind of go phrase by phrase. I can buy a skateboard for $60 and, so it's an addition, rent safety equipment for $1.50 per hour. If I start writing that out, I have $60 I have to pay and is adding $1.50 per hour. This word per means to multiply. So I take my $1.50 and I multiply it by how many hours, which I don't know, so that's my H. Alright, then it says, or you can rent. So I'm going to set that equal to. Or you can rent all items you need for $5.50 per hour, and here's another per. So that would be 5.5 H. I'm trying to make the decimal points bigger. Alright, now when I look at this, I have an equation that I need to solve for H. The H's are on both sides of the equal sign. So I'm going to subtract my 1.5 H, because that's the smaller one. I have 60 is equal to, when I subtract, I get 4H. Now I need to divide both sides by 4, and H is going to be 15. So the question was, how many hours must you use the skateboard to justify buying your friend's skateboard? I'm going to answer that, and I'm going to say 15 hours. Okay, that's when both of them are the same price.